Hello everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire and today we've got Alluri who has just completed the course Linux Basics for Robotics and he'll be giving us a presentation on that. So without any further ado, let me now hand over the platform to him so he can begin his presentation. Alright, whenever
Thank
you're
you.
ready, Alluri.
Yeah. So shall I just start with the real robot simulations?
Yes, let's do that. You can be explaining
Perfect.
what you'll be doing, right? That's part of the
Okay.
presentation.
Yeah, sure. So right now, what I'm planning to do is run the obstacle avoider bash script.
Mm-hmm,
Along with that, I'm gonna run the statistics script too, so that we can see where the robot has moved and what's its current direction, orientation, and all. Let's get into it.
mm-hmm,
Okay. So first, we'll have to open the simulation. So the command for that would be like this: source, your simulation WS folder, and install.
I think you left a
And we're gonna set
space.
it. Sorry?
You left a space between source and
Yeah.
yeah, okay.
Yeah. Perfect. Yeah. And now we're gonna launch everything. ROS 2, launch. Robotics.
Mm-hmm.
Yeah. So that should launch this.
So what are you going to be using this for? Can you just
Okay,
give a
so this is basically a computer vision. Whatever the robot is seeing is being displayed in this window right now.
okay.
Just move it to a place like this. And now, since we have this running, we can even start with the other one, like robot interface we have to run before running anything else.
Okay.
So shall I just launch that ahead? Okay, so we're gonna change the directory to ROS to WS folder over here.
Mm-hmm.
Just give me a second. To WS. And we're gonna go inside the SRC, since that's where our bash scripts are.
Mm-hmm.
SRC. Project. And again inside the Linux Basics project.
You can use tab, it will autocomplete for you.
Sorry?
You can press tab, it will autocomplete the name of the directory for you.
Oh, all right. Hmm. Yeah, I'm missing a slash over here. So, okay. And now we're gonna run the robot interface Python script.
Mm-hmm. So once you start typing like that, just press tab.
Oh, okay. All right. And let's wait for the ready message and we can proceed further.
Mm-hmm.
Perfect. Okay. Okay. So now we are ready to run the obstacle avoider and the statistics script. For
Okay.
that, we'll again have to come back to this directory in another terminal. Okay. Yeah. Go to press tab, right? Yeah.
Mm-hmm.
Six project. And in this, we're gonna run the robot statistics, no, robot obstacle avoider.
Mm-hmm.
So that's gonna be like And simultaneously, we're also going to run the statistics one. For ease, I'll just copy this.
Mm-hmm.
Did I? Yeah, spelling mistake. Okay. So right now you can see that the rover is moving and it will not collide with any obstacle. And in the statistic scripts, you can see that the distance being covered, the direction it's facing, and other orientations that we're getting from the odometry on board.
Mm-hmm. Why is it not utilizing the open spaces, right? So right now it's just rotating. What's going on there? I would expect that it'll
Okay.
try to move in
Hmm.
directions for which there is more distance, more space, rather than just rotate.
Yeah. No, it will move. The thing is, in my program that I'm currently using, it's gonna scan the four directions: your left, front, right, and front, and calculate the best path to travel. So I have set the threshold as 0.7 meters,
Mm.
and if
Why is
there's
that?
anything lesser than that, sorry.
Why 0.7?
It's more apt and suitable for any rover applications in this case.
Do you understand that 0.7 is um the greater part of a meter, right? So that's 70 centimeters,
Hmm, hmm, hmm.
right? So that means your robot is actually not finding where to go because of that threshold. That's number one. Number two, if you've seen what it has
Okay.
just done right now, it has moved towards the wall rather than away from the wall. So there's something going on
Hmm,
there.
hmm, hmm.
What is it?
Mm,
And if you've seen during the course of its
mm,
scanning, right? Of the three times that
mhm.
I've seen it scanning, it scans and then it moves towards that corner. So there is a lot going
Yeah.
on that is not supposed to be going that way, right?
Hmm.
So can you
Excellent.
take me through your code and try to explain to me what you did?
Yeah, sure. Let me come with code. Let me just zoom in on this.
I
Yeah,
still
can you
want
see
to,
the code right now?
yeah, it's fine. I still want to see what the robot is doing. So let's remove the notebook on that other end. So we can drag the IDE all the way to the left.
Yeah, yeah, got it. Okay. Would it be okay now?
Yeah, it's fine.
Right. All right. So this is the obstacle avoider bash script.
Mm-hmm.
So the first line is the shebang line telling basically we are choosing the interpreter that we're going to work with.
Mm-hmm.
Then we have the source line to get all our setter and getter functions written in the robot functions.bash.
Mm.
This is just for your echo is just printing out whatever it's giving, and we are setting the initial linear velocity and angular velocity to be zero. That is, it should start from rest. And as I told, I have set the threshold to zero point 0.7.
Yeah, that's
That is
also
meters.
okay. So
Yeah.
that one is too
Mhm.
much. Let's change that to point 0.3, right? So as we go down the script, so let's change that to point 0.3, and then we can stop
Okay.
execution and re-execute one more time.
Okay. Yeah.
I think it's a different one. So it's in terminal 3.
Um, yeah, yeah, yeah. I'll just run this again, like let this keep executing. We'll just go here and
Okay.
stop this. Yeah.
Okay, so let's wait for it to execute, but you can continue with the explanation.
All right. Next we have the do while loop that's gonna run as an infinite loop. It will
Mm,
keep checking your condition and it'll keep going through it. And over here we have all the parameters that we are getting from the robot functions script. We have written the parameter get functions in the other code. From that we are getting the parameters over here. And right now there are exactly five parameters if you note it. and the directions are left, front right, and front. We're going to get how much distance the rover has from any obstacle so that we can make a code accordingly. And out of these all six sensor values, we are using three like conditions. The first condition is forward left being blocked and front being blocked or forward right being blocked. For that, what we are going to check is if front left that we are getting from the rover is less than the threshold, and we have given a BC minus 1. This basically means that we need an integer value and not any decimal value
Okay, so
for executing
so
efforts.
okay, there's something that I want to see that I want to ask you, right? So besides having your implemented logic, do you understand what is the purpose of the threshold? The threshold value, do you understand what is there for?
Yeah, so it's basically for an obstacle. If you get any obstacle within that range, we are telling that we have to change course or do anything like any modifications. That's entirely what our code is functioning on, you can say.
Right. Okay. All right. So you're saying that the threshold is the minimum distance that we allow. Let's
Hmm.
say let's say it's actually the greatest distance that we allow the robot to get uh, as
Hmm.
close to obstacles as possible, right?
Yes.
Right. So with that in mind, can you explain to me why your logic was causing the robot to go towards the wall rather than away from the wall, right? Especially if you had the threshold of zero point 0.7. That is a very big value. It must have driven all the way out of that corner on the top left, right?
Mm-hmm.
So I want to understand if it's a mistake, you can tell me, no, I made a mistake here, but I have
I
to,
think I made a mistake.
yeah,
Yeah.
I have to ask you so that you help me understand what is going on within the logic of your program that is failing um, and not causing the robot to behave in the way you expect, right? That is giving a distance of zero point 0.7 away from any obstacle that we find in our environment.
Hmm. I think point 0.7 was a bit too large, like 70 centimeters, as you said. It's gonna cause the rover to. Okay, so what happens is point 0.3 is lesser distance from the obstacle, and the rover can immediately change. But point 0.7 makes the rover feel that it can go further, and it's colliding with the walls over here.
Yeah, but yeah, okay, good. You do get what I'm trying to convey to you, right?
Hmm.
And but my question, if you remember my question, it was with reference to the behavior that we saw at the beginning, right? So your robot would
Mhm.
rotate and then move towards the wall, rotate, move towards the wall, right? It's
Yeah.
exhibiting the exact opposite behavior that we want, right? Or that we expect from
Hmm.
a point 0.7 a zero point 0.7 meter threshold, right? So
Hmm.
from where it started spinning, that distance was very much smaller than zero point 0.7, right? It must have moved away from the wall or from that corner, at least towards the center, right? Because that means your logic was functioning correctly. It was realizing that the robot is too close to an obstacle, i.e., the threshold is,
Hmm.
or let's say the distance that the ranges is giving is less than the threshold, so it has to increase the distance from obstacles to beyond zero point 0.7, right?
Yes.
Yes. So my question to you was, where do you think your logic is falling short? That's why I'd asked you to go through your script, your obstacle avoidance dot bash.
All right. I feel like there's a mistake in your if and else statements over here because forward left blocked is returning it as one,
Mm.
but I think if it's greater than, it might work. In the case, I give it 0.7 and I put parameter front left is greater than threshold. I guess in that case, it might work.
Yeah, okay. Yeah, yeah, I would agree with you. So what I would say is you would have to check these, right? And
Hmm.
get a full understanding of where it might be falling short. However, right, the thing that I want to make clear to you is that zero point 0.7, even though I say that's too big, right? If the
Hmm.
logic there was good, right, your zero point 0.7 would have worked anyways, right? It would just excessively restrict the possibilities of the robot to move around, right? But the the logic would still work, right? It would still be able to find places where it is a threshold of greater than zero point 0.7. I get it is a distance of greater than zero point 0.7 from obstacles, right? So you have those two things to make amendments to, right? However, I would recommend that from now on, do not use any threshold value that is greater than point 0.3, right? So always stick to that. So that is 30
Hmm.
centimeters, i.e. zero point 0.3 of a meter. And then everything else that goes wrong, look at your logic, check where things might have gone wrong. The threshold is actually fine. It's not going to do much for you. The worst thing that can happen when your threshold is maybe too little is that your robot will like get too close to obstacles before avoiding them, but that's not a big issue, right? When we give you that value,
Okay.
we know that it will do for your tolerances, given the whatever speed you're working with, as far as latency is concerned,
Hmm.
right? So look at your logic, focus on that, and then that will help you to fully understand what might have been going wrong here, okay?
Right. Okay.
All right, so what you're gonna do is we're gonna wrap it up here, and I suggest you hang on, and then we'll finish our conversation on Zoom. All right, Aluri?
Yeah, sure.
All right. All right, everyone. This was Aluri's presentation, and I highly encourage all those of you who want to try this course to also do the same thing, and then you can also come and showcase your work. Until next time,